Interestingly, when we get out, it is the same as the other one. In other words, any search algorithms will exit when you can confirm either the item is in the array or you can confirm the item is not in the array. Whether you're using binary search or linear search does not matter because you still get out of the loop because of the same reasons. Well, we'll go ahead and call this revision 1. Okay. How do we confirm an item is in the array? Yep, same thing. So, but this time I would use a different number. I'll use a bracket m instead of a bracket I. Okay. So use m as the index variable to indicate which element we are examining in an iteration. Okay. Very good. And what is so special about binary search anyway? I mean, what makes it different from linear search?
It starts in the middle.
It starts in the middle. Very good. So that means, this m here is related to which part of the array may still have the value that we are looking for, and this has to be the index within, right at the middle of that range. Okay? Let me just tell those guys to kind of. They don't have really good seals for these windows, so thank you. All right. So the next question now is how do we represent that? In other words, I have an array. Now, with a deck of cards, I can just say, toss one half away or physically remove it. But when you're talking about an array in the memory of a computer system, you cannot just get rid of it, right? So instead of getting rid of the half that cannot possibly have the value that I'm looking for, I'm going to use bookmarks. Okay? I use one bookmark to say that this is where the array may start to have the value I'm looking for, and this is the end of the range of elements that may contain the value that I'm looking for. Okay? So we are going to introduce 2 additional variables in this particular revision. So we'll basically introduce b as the index of the first element that may have the value k. We also introduce another variable called e as the index of the last element in the array that may have the value k. In other words, now I have 2 bookmarks. One bookmark marks the beginning of the range of the entire array that may have the value k. The other one marks the end. Initially, guess what? B is all the way at the beginning, and E is all the way at the end, because before the first comparison, I cannot throw anything away. But for each comparison, I can either move B closer to E, like this, or I can move E closer to B, like this. Okay, so by moving B and E based on the comparison, they will get closer and closer together. Is that making any sense? Okay. Doesn't that give you an idea of how we can express the item is confirmed not to be in the array in this case? Well, what happens when they are the same? When they are the same according to the definition of B and E, the beginning of the range of the array that may have the value I'm searching for and the end of the range of the array that I'm searching for are now the same. What is it saying? It means we have one last element that may have the value k. So it's not time to quit yet. But when they go beyond each other like this, then it's time to quit. Okay? In other words, when the beginning has gone past the end, then we have a problem. So that means that the other one, when we can confirm the item is not in the array, is when B is greater than E. Because the B is the beginning, E is the end, If the beginning is passing the end already, then we know that there are no elements left in the array that may have the value k. Is that okay? So now the question is, we have all these variables. How do we relate these guys to each other? Okay, so in the next revision, I will finish this part here today and then continue to explain it next week. So the way we compute m is like this. M is going to be the floor of b plus e divided by 2. Basically, it's the average of b and e. Because we are looking at b is over here, e is over here. I want the middle of those two. And then we'll say if a bracket I or a bracket m is less than k. If a bracket m is less than k, which one do I move? Do I move b or do I move e?
You move E.
I move a bracket m is less than k. So that means everything before that would be less than it, so we move e. So in this case, we move e to become m, but not just m. It becomes m minus 1. Okay, because a bracket m itself also has to be removed from that range. So I cannot make it m, I have to make it m minus 1 to make sure that I don't look at a bracket m again. The other case is, what if a bracket m is greater than k? Then we can throw away the other half, which is b. So we have to move b forward. And by doing that,
m plus 1.
I'm thinking, is it reversed? Because if a bracket m is less than k, that means everything before that cannot be. So I think I got it flipped. Okay, let me fix that. Okay. So that's basically the idea. Every time you go through an iteration in binary search, you compute the index of which one should I be comparing for this particular iteration. Based on the comparison, you either throw away the first half or the second half. If it matches exactly, hey, not a problem, because we will exit when they do match exactly. On the other hand, if B is exceeding E, that means there's nothing left in the array that may contain the value K, and it is also time to exit to conclude that the item cannot be in the array. Okay, so we'll stop here and then continue from this point on next Tuesday. But please read ahead of me so that you have an idea of binary search, what binary search is, and how it works. Yep. I'm still in progress.
Okay.
Yep, it is still in progress.